moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. The closer the moon is to the horizon, the larger it looks. This phenomenon is called the moon illusion. One of the theories explaining it claims that the atmosphere plays the role of a magnifying glass, which makes the moon look bigger. In reality, if the atmosphere had a say in it, the moon would actually look smaller, not bigger. Most experts believe that the illusion is created by your own mind. It can increase the moon's size more than twice. When Earth's satellite is high up in the sky, you don't have any visual cues about how far away it is. But when it's near the horizon, you can see objects surrounding it in detail. It makes the moon look larger. But it's just one of the many theories explaining the phenomenon. By the way, you can trick yourself out of this illusion if you bend down and look at the moon upside down through your legs. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long, though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020's CD3, are rare. They need to have specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. A transient lunar phenomenon is one of the most enigmatic things happening on the moon. It's a short-lived light, color, or some other change on the satellite's surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes, but there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the moon. One of the mission participants noticed that one part of the natural satellite was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. There might be more metals, for example titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the moon's? It might mean the moon formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would be easier to walk on the moon's surface, but it would be more dangerous too. Your feet inside a heavy spacesuit would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden under the surface of the moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared in the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. There's no air on Earth's natural satellite, but then how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. But even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. The Earth and the moon are gradually drifting apart, as slowly as your fingernails grow. This is the flip side of our satellite's gravitational force. The moon creates tides in the Earth's oceans. They pull back at the moon and make it speed up. This, in turn, moves the satellite to a higher orbit. In prehistoric times, the moon was way closer to our planet than it is now. Luckily, we aren't going to lose the moon. The farther away it moves, the weaker its gravitational pull becomes. It means that soon, our planet won't be pushing the moon away with such a force. There's very little activity going on inside the moon. Plus, there's almost no atmosphere around. That's why scientists can trace impact craters littering the satellite's surface back billions of years. While dating the craters, astronomers discovered that the moon, along with our planet, went through a late heavy bombardment about 4 billion years ago. This event is also known as the lunar cataclysm. This interval lasted several hundred millions of years. During it, an unusually large number of asteroids collided with Earth, Mercury, Mars, and Venus. There might be a labyrinth of lava tubes on the moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface, about 30 miles long and 60 miles wide. The cave's likely to be the result of 3 billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the moon's surface, discovered by NASA, might be the openings to lava tubes. The moon's orbit around the Earth isn't a circle, it's an oval. That's why the distance between our planet and the satellite varies from over 225,000 miles to more than 250,000 miles. There's very little seismic activity going on inside the moon. Yet, many moonquakes caused by our planet's gravitational pull sometimes happen several miles below the surface. After that, tiny cracks and fractures appear in the satellite's surface, and gases escape through them. Have you ever wondered why Earth doesn't have rings? Gas giants, Jupiter, Saturn, Uranus, and Neptune, have them. But the rocky planets, Mercury, Venus, Earth, and Mars don't. Two theories describe how ring systems potentially developed. The first one says that rings may have formed from leftovers that date from the time a certain planet was forming. Or, as the second one says, they could be the remains of a moon that was either destroyed in a collision or broken apart by the gravitational pull of its parent planet. Scientists still don't know why the gas giants have rings, but they think it could be because they formed in the outer solar system. Rocky planets formed in the inner area of our solar system, which is why they were more protected from potential impacts and collisions that might have formed rings around them. Or the reason is that the bigger planets have a larger volume, which allows a ring system to remain stable. Some scientists think our planet did have a ring system a long time ago. In its early stage, a Mars-sized object hit the Earth, and this probably resulted in a dense ring of debris. But its ring system pretty soon coalesced, and that's the way our moon was formed. More than 10 years ago, in 2011, astronomers found a huge water vapor cloud about 12 billion light-years away from our planet. This cloud is the oldest source of water that we know of. It dates back to when the universe was only 1.6 billion years old, and now it's 13.8 billion years old. This unusual cloud is also the biggest source of water that we know of. It holds 140 trillion times the amount of water that the Earth contains in all its oceans. Enormous. The cool thing is, this vapor cloud is kind of feeding a black hole. It may contain enough gases, such as carbon monoxide, to help its black hole grow even 6 times bigger than it is now. We all know that Earth has one moon, but there are 2 more asteroids, 3753 Carina and 2002 AA29, locked into co-orbital orbits with our planet. The first one doesn't really circle around the Earth, but has some sort of a synchronized orbit with the planet, which is why it looks like it's following the Earth in a stable orbit, while in reality, it has its own specific path around the Sun. The other one, 2002 AA29, follows a horseshoe orbit around our planet. Its specific path brings the asteroid closer to us every 95 years. You'd expect Neptune to be an extremely cold and dark place. After all, it's an ice giant 2.8 billion miles away from the Sun. There's not too much sunlight there, so noon on Neptune is similar to twilight on our planet. But this ice giant appears to be creating its own heat. To be precise, 2.6 times more heat than it gets from the Sun. This probably has to do with all the pressure near the planet's core. It builds and releases hydrogen, which keeps Neptune's center at a crazy temperature of 9,300 degrees Fahrenheit. But its atmosphere is still quite chilly. It ranges from about negative 240 degrees Fahrenheit to negative 330 degrees Fahrenheit. What shape do you think of when someone mentions storms? Probably long ovals of hurricanes and conical tornadoes. But that's something we see on Earth. At Saturn's North Pole, a storm has been raging for at least the past 40 years, and it has a hexagonal shape. Such a weird shape probably has something to do with Saturn's turbulent gas, or maybe even with zonal jets that extend many miles down into a region of extremely high pressure. Have you ever wondered why planets don't twinkle while stars do? The thing is, if you were out there in space, you wouldn't see them twinkling at all. The reason we see stars twinkling is because of Earth's atmosphere. The pin-sized light coming from a star hits the atmosphere. The atmosphere then refracts it, which sends the light skittering off in a zigzag. That's what we perceive as the twinkle. Planets appear much bigger to us than just pinpoints. And yes, their light zigs and zags after hitting the atmosphere too. But those motions cancel each other out, which is why we don't see twinkling, but only a steady glow. In some regions, you can expect big changes in temperature. For example, in Montana, where in a single day, temperatures went from negative 54 degrees Fahrenheit to 45 degrees Fahrenheit. Yeah, sounds like a lot, but it's still nothing compared to Mercury, where temperatures tend to vary over 1,000 degrees Fahrenheit in a single day. They start out at negative 280 degrees Fahrenheit at night, and eventually go up to 800 degrees Fahrenheit during the daytime. Picture a wardrobe you'd need to prepare for a single 24-hour visit to Mercury. Why doesn't the atmosphere of our home planet vanish and disappear into the vacuum of space? Even though we can't see them, the gas and vapor molecules that our atmosphere consists of all have mass. As such, all of these molecules feel the gravitational pull of the Earth, just like we do. They could escape, true, if they had enough energy. For instance, if our planet was closer to the Sun, the atmosphere would be hotter, and its molecules could get away easier. But the Earth, fortunately, is just at the right distance from the Sun and has exactly enough mass to keep its atmosphere in the same place. When you think of volcanoes, you probably picture hot molten lava coming out of them. At least, that's how it works on Earth. But in space, volcanoes can spew methane, water, or even ammonia. Up there, a volcano can also spew specific materials that freeze as they erupt. Then they turn into frozen vapor and some sort of volcanic snow. It's a common thing on Jupiter's moons Europa and Io, also on Pluto and Saturn's moon Titan. They're called cryovolcanoes, and Io has extremely active ones. Over there, you'd see hundreds of vents with plumes of frozen vapor that tend to extend about 250 miles. And NASA vehicles have even captured some erupting in real time. Bam! Planets, moons, asteroids, comets, and stars, they can all collide, and galaxies too. Our galaxy, the Milky Way, is 2.5 million light-years away from Andromeda, our closest galactic neighbor. Astronomers believe the Milky Way is on a collision course that will destroy both galaxies in the distant future, or at least galaxies as we know them. The two galaxies are going faster and faster toward each other at a rapid clip, 250,000 miles per hour. It will be chaotic, and many planets and stars won't survive the collision. Eventually, these two massive entities will merge and turn into a completely new, unrecognizable galaxy. But here's a small comfort. Scientists assume this is not scheduled to happen for another 4 billion years. In case you want to fuse two pieces of metal together, you already know the only way to do that is to apply heat so these pieces can reach their melting points. In space, you don't need heat to do such a thing, or basically, any action at all. We call it cold welding, and such a phenomenon happens when you slide the metal pieces over each other. In that case, they wear away their protective oxide layers. On Earth, these layers stop them from fusing, but in space, this type of protection disappears. That's why the electrons from one piece of metal just flow into the other piece. And ta-da! They're one without any effort. Scientists used to believe the Earth was the only planet in our solar system with tectonic activity going on. Tectonically active means plates under the crust are moving. This process releases heat, which then deforms the Earth's surface and leads to its shrinking. But now, we know this happens on other planets too. Mercury is also shrinking, and scientists found it out in 2016 when the Messenger spacecraft orbited the planet and sent back some important data. It revealed that there were cliff-like landforms known as fault scarps on Mercury's surface. Since these landforms are relatively small, they probably didn't form that long ago. That means Mercury is still contracting, even 4.5 billion years after our solar system was formed. Jupiter's Great Red Spot is shrinking as well. It's a huge storm that rages on the planet's surface. It's reddish, a bit oval in shape, and more than 10,000 miles wide. Yep, that's big enough to swallow the Earth. And now, it's been slowly but surely shrinking for a couple of centuries. The Great Red Spot is just one of many high-pressure storms that occur across Jupiter due to all those gases present there, which is something that classifies Jupiter as a gas giant. But just because it's shrinking doesn't mean the Great Red Spot is going to blow itself out anytime soon. It's even growing taller.
It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is, nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the Moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the Moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the Moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the Moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the Moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the Moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the Moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the Moon and the one farthest from the satellite. But that's not all. The moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say that the moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike the grape, the moon doesn't have flexible skin. Its surface is hard and brittle, so as the moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the moon? A recent study claims that it has a tail. And every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium. And our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet. Called 2020 CD3, it was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction.